All right, welcome everybody. Here's Mr. C. This is a short YouTube recording for Lab 806 where we investigate electrical circuits. It has three parts, a quick overview of it. The first part is we're going to determine the resistance of one light bulb, and I'll show you how to set up the circuit. There's a table for you to be used and go through step by step. Part 2 is then where we're going to investigate voltage and currents and ultimately the equivalent resistance here of bulbs in series. Bulbs are just resistors. They're nice because we know if current is flowing by seeing the light go on and off, but they're just basically resistors, and we can investigate those. Third part is we're going to do the same thing, setting the circuits up in parallel. Of course, the number of bulbs, if you have just one bulb, one resistor, there's nothing in parallel. This is kind of your reference measurement, always the first line, and then we go into the parallel, having two bulbs in parallel or three bulbs in parallel. The same is, by the way, true with one resistor, right? There's nothing in series there, but it's kind of should give you the same readings on all the experiments we do. Let's hop right in. I have this virtual lab open here. That's the setup as it pops up at the beginning, and I have to say it's a little tricky. At certain points you can't just drop things. The hand will not allow you to do that, so that's why I want to do this recording. Let me draw over it a little bit here. Hope I can use this ink tool here. Use some blue here. So this device here is the battery, and we're going to manipulate the battery by dialing this dial and the switch at once. In the lesson you might have seen it separately. Sometimes they draw a little battery there, plus, minus, and then there's a separate switch here. But this is all in once, and it shows us even the voltage that this device has. It might make sense at the beginning at least to measure that voltage using this voltmeter. It looks very different. It says V here, so that means it's the voltmeter. This is our ammeter, measures the current in amps. And these are our three resistors. These are single wires, so they have just two connectors, and these are split wires. We're going to use them quite frequently here in the setup. These three terminals in this case, or even four terminals, these ends of the wires are called terminals, are all connected. So there's a continuous connection from here to there, to there, to there, whenever they are. And they can be stretched, but only so far. So let me erase. I wanted to erase it. Okay. This was a screenshot too. So back to the lab. First, we're going to measure the resistance of one bulb. So you grab a bulb and place it a little bit away. You want to use the workbench openly quite a bit, not make things tight. We're going to measure the current going through that bulb. So we're placing an ammeter here, and for the first time we also want to measure the voltage across the bulb, but we expect that to be the same as the voltage of the battery, right? And now we need to connect things, so we're dropping these, and you see this stop sign or no traffic signal, so I can't just drop it anywhere. I have to drop it where the shadow below has some space. I'm gonna drop those now, and for the voltmeter and the resistor, I like to use four terminals connector, and I do it deliberately because if we don't connect one of them, it just hangs in the air. It's okay. If we don't use it, that's all right, but I don't have to. In this case, I can just use a three terminal one, but either way. So now you connect them by holding your mouse over it, and then the hand changes, and now you can nicely connect those things. They make a little click sound even. Very elegant way of doing it. Trouble grabbing this thing here. Oh, I grab one of them. I can't grab any of them. Now I have one. Alright, here goes one. Here goes the other. Hey, here goes the third. Alright, I like this one. Oh, we connect this guy here, this one there, and this to the battery. And I tell you what voltage to do it at. I think we're doing it at beginning at 5 volt and then increment in 5. So I turn this dial over as good as I can to 5 volts. It's a little bit tricky here. If you're not hitting it exactly, don't get frustrated. You can always write the value in that you really have. And so what we have here is, before I do the experiment, again I go into my Inkspace here. Let's see. I like this tool, so I can draw on it. So what we have here really is a battery, plus, minus. We have the switch in this case on the bottom. That doesn't really matter. I'm gonna draw it here for you. And then we have our resistor here, right? The resistor is here. And let me switch colors. What we really have is, we have now the ammeter built in. So this ammeter is kind of inbuilt in here. I'm gonna measure the amperage here. And the voltmeter is in parallel here. That's how the setup is. And this terminal that's floating is just in the air. It's not connected to anything. This is an isolating table. So that's how we have the setup. So when I now close the switch, we expect this voltage, because it's in this voltage here is parallel to that one, showing up at the resistor, and then we measure the current, right? So let's go back here. Really do that. You click here and you close it. As you can see, the 5 volts show up parallel to the lamp. The lamp lights up and we have 1.7 amp. So you're gonna write into the table in the lab report. Let's see if I can pull that one up again. Here you have, okay, for 5 volts we have 1.7 amps. And you're gonna do this successfully all the way up to 25 volts. And then you graph it. You graph the current versus voltage, which is opposite to what they tell you in the lessons. So a bunch of things that are a bit tricky here. Let me bring up this thing again here. So when we draw Ohm's law, it's normally I equals U times R, U over R. So the higher the resistance, the smaller the current, right? So what they ask us to draw is the current exactly like it's shown here. We're gonna draw the current on the y-axis. I goes on the y and the voltage goes on the x, and you're gonna get the line. The higher the voltage, the higher it is. But the slope of this line is really representing, as you can see, it's like 1 over R times U. So the slope of this represents the slope you're getting here is in units of 1 over R, in units of 1 over ohm. They have actually separate units for the Siemens, but we're not using that. So when you get the slope value here, you need to flip it around and then you know the resistance. That's also indicated in the table to you on the bottom there. I move the Word document over, here it is. So you're gonna get the slope here and then you inverse it to get the resistance. Not too hard, and I even mention it here. So now let's set up a circuit here, and you have the data for one bulb already, right? The current through one bulb, but this time I ask you to set the voltage at 16 volts. So basically go back here. Let me close this. So if you set the voltage to 16 here, 15. I wish it was digital. We're wasting some time here getting to the right voltage. It used to be like you had to do it manually by dials. Okay, I'm fine. 16 volts. And we close the switch here. You see it's 16 volts at the bulb and it's 5.4 amps. So that's the one you would write in here. The current through one bulb is 5.4. The voltage on one bulb is 16.1. The total measured current is the same as the one for a single current. So I'll even type it for you. So here it would be 5.4. Here we had 16.1, a little bit off. The total measured current is also the same as the one we measure for the one bulb. You're going to calculate the resistance here. You have enough information. The reason why I color this, just use the resistance of this data here. So you're going to calculate, I don't give that away. The calculated total current is then, once we have different current values here, this would change, right? Measured total current calculate. Oh, this is then you calculate it. I'll show you how to do this once we have enough more data points there. The sum of the voltages, once we have, well, the sum of the voltages would be 5.4, and the equivalent resistance is the same resistance that you calculated for one bulb, right? So these two fields, I can't highlight them in here. Let me go back to my magic tool here. So let me go back here. Let me not use red here. Blue, get that. So calculate the resistance of one bulb R equals U over I. So you have the current through one bulb here, you have the voltage through one bulb, so you can calculate that resistance. The total calculated current in this case is then you take the calculated resistance and the applied voltage. In this case it is this voltage here, and calculate the total current. In this case it's the same, it should be 5.4. The sum of the voltages, sorry I didn't write it right, it's 16.1 in this case, we have only a 1, and the equivalent resistance is also whatever resistance you got over here. Okay, so let's set it up for 2 bulbs. That's where I think it gets a little bit more tricky. First thing, you have to clean up. You have to clean up, to start basically over again, largely because you have to organize things. So you have to unplug all these things, and we do now a circuit in series. So move things aside. Need to make space for it. Alright, so we move you guys over here. Okay, we want to do 2 in series. We're gonna measure the current here. We're gonna put a second bulb right here. Okay, so they're in series now. I'm gonna measure the voltage across one of them. So we pick the lower one, seems to be more space here. And now we start connecting again. Okay, so I connect this guy, and they're not infinite long. That's the trouble with it. I might run into trouble now here. That's okay, I can still stretch it out. Alright, so now the middle one, I just use the 3 one. Can I drop it here? Anywhere? I could drop it here. There, alright. So I go here, here, and I measure the voltage of the lower resistor, the lower bulb, by connecting it here. I thought so. Yeah, let me get in there. Why doesn't it let me in there? There's a little more space here. Now it worked. Okay, so sometimes it doesn't look like everything is alright, but so now we have connected these, and the last thing is we could have left the ammeter same. Go in there, and then let's drop that here. I hope you see that the 2 resistors, the 2 bulbs, are in series. I want to get it in the top. Okay, you want to go in from the right? Come in from the right. Let's see what happens. I think it doesn't matter, but let's see what happens. And we need to set it to a voltage of 16 volts again. We leave the voltage constant, and I just want to see that light bulb lighting up. As you can see, the current flows through the ammeter, through the first resistor, over here, and then through the second resistor or bulb and back. And all that circuitry here to the voltmeter does not draw a lot of current. The voltmeters have a huge resistance. Ammeters have a very low resistance. So what happens when I close it? It lights up, and I think I verified that it doesn't make sense. It doesn't make a difference where we connect the second terminal for the bulb. I just want to see one time if I can get it to the top. Yeah, now I can. I like to have it clean, so if I close it again, yeah, it's the same value. So we measure 2.7 amps going through the circuit, 8.1 volts on one of the bulbs. Okay, so now let's go back to my lab report. report. Do a bit more detail than I thought I would do. The current was, I don't remember, I can just click 2.7, 8.1. 2.7 amps. Through one bulb it was 8.1. Total measured current, then it's the same. In series there's only one current, right? So the total measured current would be 2.7 amps. The calculated resistance of one bulb, so now we have, this is the current, this is the voltage of one bulb. So we say equals, right? In Excel you say equals, you divide this amount by that amount. It's about 3 around, right? 3 ohms, you're gonna calculate that. The total calculated current, you take the sum of the voltages now. Here would be, you take two of these voltages, right? One for each bulb, and you have the total current here, and so you can, now you have the total voltage then, you have the total voltage here, you have the total measured current here to get the total calculated current. It should be the same as the one you measured here, close to the 2.7 amps, right? The sum of the voltages, that's easier. So we have two resistors, each of 8.1 volts, so the sum should be 16.2, a little bit higher than we thought. There's some rounding involved, right? And then the equivalent resistance is the sum of the two resistances. So the calculated resistance of one bulb, we have two of them, so multiply this resistance here for this field with 2 by 2. Okay, and you try to set up a third bulb in series. It gets fuller, it's a bit challenging to set up the circuit, but you can do it. You only measure the voltage on one of them, but you're adding basically another one. Let me try to do it quickly, if I can show you how to do this. Try to have you not struggle. So if we put it, say, over here, and then connect. So you see, it doesn't let me it doesn't allow me to drop it anywhere. We connect this here, and the second one there. Yep, it works. So now we have 3 bulbs in series. If I close it now, the current drops even further. The voltage is reduced too, and so you get your data that way. The rounding gets a little bit more ugly because 3 times, no, it's 15, 3 times 12 is 16.2. You see, if you multiply the 5.4 volt by 3, because we have 3 of these bulbs, you end up close to the supplied voltage. That's for the series circuit. Let me set up one of the parallel ones, but I'll let you then do the rest of the work. Just we need to clean up here first. So a parallel circuit, because you want to measure the currents there, so that's the tricky part here. Alright, I hear someone in the Class Connect session. Let me pause this recording here. Alright, I'm back, and this is I took a short break here, answered some questions, so I hope this works. I have a Class Connect session in parallel to this screen recorder, so we wanted to set up parallel circuit, and the first one was clean up, you know, the thing. Oh, I don't use it's easier with the mouse in this case because I can click. So we grab these things, we place the wires out of the way. The ammeter goes this time, actually one time into the whole circuit, so we're gonna measure this current for the whole circuit, and one time into a branch of a parallel circuit. So I leave it here for now, but we definitely don't need the second bulb, the third bulb. We're just working with 2 bulbs here, so they go in parallel, and I'm gonna change those things too. I measure the voltage. Okay, so now we probably need the split wires with all terminals this time. Okay, so Gonna start connecting. Gonna connect those two in parallel to the bottom of the battery, and not only do we put the bulbs in parallel, I want to know the voltage too. I can reach it, yep. Alright, so on the top now we have to do a split wire with 4 also, and we're gonna connect those two and the top. So the current now flows from the battery through the ammeter, splits up into two currents for the two bulbs, and then combines afterwards and goes back to the battery. There's no current that goes through the voltmeter. The voltmeter current is very small, there's a huge resistance. So this way you're going to measure the total current that goes through the two bulbs here, and we measure the voltage on one of the in parallel. Bye, Cole. So if I turn it on here, it lights up. We have 10.7 amps. No surprise, 16.1 volts, the same as is measured on the battery itself. Okay. Now we also want to measure the current going through one of the bulbs. So not the total one this time. That needs to get removed here. I'm going to measure that current going through one of them. So I'm going to grab this guy, go in here, unconnect this one, go there. Second terminal goes here. It looks quite messy, but I hope I can reach this one. Can I reach it? Yeah. Because the way the wires are, but I hope you see that the current measures now the current going through the left bulb. So when I turn it on, I measure 5.4 amps. Okay, very small, about half the current we had before. Okay, because we build it into the left branch. You don't have to do the right branch, but you know that they're the same resistances, so it's probably the same current, right? The 5.4 amps. And the voltage is still at 16.1 volts. So this is enough of a recording, I hope, to get you going. Otherwise, please come to a Class Connect session and ask questions or send me an email. Thank you very much.